Okay, I've started the recording. Welcome one and all to Blackboard is Screwed Update. According to Blackboard, I have approximately 100 too many students in here right now. Just saying. Congratulations, I now have 20 students registered in my class. Way up from yesterday, which was 1. Congratulations, Richard. You were the only one in my class the whole time. I don't know why you picked you, but hey, you got it. Yeah, Blackboard has soiled the bed. There's nothing we can do about it, as Howard's been trying to tell you guys. Assignment 1 was due today. Obviously, it's not going to be. Right now, I'm moving it to the 26th, pending further cluster fudging. So, congratulations, you all got a 2-day free extension out of my control. Yay. So for those of you who said they need an extra day, congratulations, you got 2. You know, that's, you succeeded, botnet success. Yeah. Okay. However, the other 2 sets of due dates are not changing in the short term, just so you know. I'm pretty sure November 21st, hopefully by then they've got things controlled. Yeah. Well, play it by ear, dude. It's the world of IT. Nothing ever happens when it's supposed to happen, and when it does, it's because something else broke. That is essentially life. Okay, so that means you got 2 extra days to submit it. That also means that the drop dead date also moves up by 2 days. As I announced originally, you know, you submit it on time to get all your points. If you're late, you get up to a week with a 10% deduction. After a week overdue, then you get 0. So, you know, technically, if you're willing to take a hit and take more time doing your work, you got to gamble whether or not it's worth a potential 10% hit. Since it's worth whatever number of points it is, off the top of my head, I don't remember, 35, I think. That means you'd lose 3.5 points off the top. Generic deduction. And it's not, you know, 10% of what you would have gotten. It's 10% if you got 100%. All right. So, what are we going to cover today? We're going to cover more SQL. Because that's what we're doing. As most of you have discovered, Lab 6 is fairly straightforward compared to some of the other labs we've had so far. Lab 7 is technically even easier than Lab 6. As long as you know, sort of pay attention to the lecture and sort of, you know how to Google for the word SQL select statement. I had people asking me for help last week during the labs, and I'm like, here. I went to Google and I typed in, select create table. I mean, SQL create table, enter, first hit. So, you know, there's lots of documentation on the internet. It's fantastic that way. I know its purpose is to share information, and it succeeds. And by the way, Stack Overflow is the bomb. All right, so I'm going to switch over to my presentation, and I'm going to kill the light. I need to start at here. There. All right, is that still bright enough? Yes. Okay, so this was actually the last slide last week where I was talking about the standard comparison operators. What I'm covering next is the next topic after the standard comparison operators is you also have to take into account how to connect to certain, actually, I need to go one more. It's how to check for patterns. I think, did I cover patterns to you guys? No, other section. Okay. I'm in the middle of between 2 different sections, and where things the other sections even more messy than your guys's. So I'll be talking about pattern matching in a minute, but there's a few things that I tend to always forget because I take it for granted. And this year I made a note when they popped up on my calendar to remind me to tell you guys this. And it's not in the slideshow. But when you're comparing certain data types, you treat things a certain way. And it's pretty easy. Okay? If you're comparing numbers, you don't have quotes around it. Everything else you use quotes. So, what does that mean? It means the following thing. Is price greater than 10? That's a number. You don't quote it. It's a quote. It's a date. You quote it. In other words, if it's a number, you don't put quotes on it. If it's anything else, you put a quote on it. Why is this important? This will give you an error. Some SQL servers will ignore the quote marks around a number and they just magically cast it to a number. Some don't. Some care a lot. However, the magic is with the date. SQL understands basic arithmetic. Therefore, if I take, for example, let's just say I was doing 2016. That's really small. I take 2016-10-1. And I look at that one. Now let's pretend these dashes, because it's not in quote marks, it thinks those are minus signs. Suddenly it becomes, this is actually going to be 2005. Because it's doing 2016 minus 10 minus 1 equals 2005. If you don't put quotes around your dates, that's what you're going to get. And if you're in the middle of a practical exam, you forget to put your quotes on a date, and I say, how many orders were placed on such a date? I'm not saying it was, that's going to be the question you get, but you know, theoretically you could get it completely wrong because you're not actually checking the date, you're checking a number. And the database server is smart enough to know that you're screwing up, and it says he must know what he's doing. All right. Was that clear? If it's a number, no quotes, everything else put quotes. Okie dokie. I'm going to erase this. Well, you guys are extra special today, too. You don't even have to worry about the magic attendance word today, because obviously you guys are not here because you're not supposed to be here. Except for the 25 of you that are supposed to be here.
So can we just leave?
Sure, you can watch the recording and just not get to ask any questions. I'm okay with that. I don't care. I'm just impressed there's been so many of you here today. Man. Hey?
It's a school day like anything else.
Yeah, exactly. All right, so last week I talked about the standard matching operators. Equals, not equals, greater than, the diamond operator. Those are the standard ones. But sometimes you need to do stuff that's not quite exact. Therefore, you need to do pattern matching. And in other words, you're trying to find a pattern in your strings. And thinking of that, I guess I should actually record the screen there. All right, so sometimes you need to find stuff that doesn't fit a set mold. And you need to use some pattern matching for this. And SQL provides a standard pattern matching library. And essentially, there's an operator that all SQL dialects have. It's called like. I want you to find things that look like this. It's the only time in your life you get to use the word like, all one, like, you know, like, I'm trying to find something, like, stop saying the word. You're not making yourself sound any brighter, like, you know. So, it has standard pattern matching. And there's two styles of pattern matches. There's the percent sign and underscore. And a percent sign matches any number of characters, any number of times until it hits the first character. Underscore matches one character. And I'm going to do a bunch of examples here on the board so that it makes a little more sense. And essentially, it shows you a few examples here. Now, Postgres is the outlier in Likeland. It did because Postgres is so case sensitive. They decided to get clever, and they called something called I like. It's almost like a thumbs up, but not quite. I like means insensitive like. You know, it's the rude version of like. It doesn't care who you think what your identity is. It's going to match you. So essentially what happens is there's several patterns, and the way you do it is as follows. Let's say we got a series of strings, and we'll actually put my name up on the board. All right, here's my string we're going to be hunting through. Now we're going to do some pattern matching against my name. I want to make sure this actually picks up completely. We're going to pattern match against my name. So the first pattern match, I'm going to put a quote mark. And I'm saying I want to find everything that starts with Dan. I should bring my quote mark in a little bit. All right, nice and colorful. Can you guys see that at the back? Or is there too much glare? Okay. So, pattern match Dan percent sign. What this is saying is grab anything that starts with Dan and ignore anything afterwards. So what will it match? It matches that, and the rest of it falls under the percent sign. So percent sign everything to the end. Like that. That's what the percent sign does. It says match any number of times. Now if I were to match all right, so this is saying give me anything that ends in T. Any number of characters until you hit T. And because there's not a second percent sign, T is the last thing in the string. So this would match. The T, and the percent sign covers everything from the beginning. So that's what percent sign T would do. Now let's say I did okay, I say percent sign A. What would happen is it would get right to the end. You end up with no match. Percent sign A. It doesn't end in A. Right? So there's, give me a match anything until you hit A, and because there's no wild card behind the A, it assumes A is the last character. Yes?
Does it sound like star A? Something like that, or finding something in Linux?
Sure.
Okay, sorry.
Sort of.
You know what I'm talking about?
Yeah, you're talking about if you did something like ls-r %sign star A.
Yeah.
right? Recursive search for an A, anything that ends in, that has A in it at the end. Yes.
Okay.
Except it doesn't use the star, percent sign. Because star was already allocated before they created the percent. Light came in later down the road. They already allocated star to select everything. All right, so here are 3 cases we got so far, right? We can match Dan because it's found at the beginning. We can do percent sign T because T's at the end. Percent sign A does not work. Why? Because the string doesn't end in A. But let's say I want to find now this is going to say, find A. Give me any string that has the letter A in it, regardless of position. So this one will go, and it'll search, and it'll match. And it'll get to here and say, oh yeah, hey, look at that. Till the end. That won't give me the string 3 times, but this one matches 3 times. Valid. Based on this rule. This is nice and cute and powerful. It does a lot of tricks. The other thing you can also do, let's say we're working with a phone number instead. Right, we have okay, so we have a phone number that looks like that. I know, guys, it's small at the back, but it's more about the pattern than anything else. I've got a phone number that looks like this, and I know I want to find everything in the 613 area code. And we know for a fact all our data is filled in like this. What we do is we do something that looks like this. And of course, that would match like that. And by the way, I should put one percentage signs in here to show you guys where it's matching. That. In other words, they'll find anything that starts with 613 because we did that. Remember I was talking about how important it was to store your phone numbers as strings so you can pattern match? Or let's say you're trying to find a number at a specific exchange. You guys know what an exchange is as opposed to an area code? That's the exchange. What used to be really important, it would actually tell the bell system where physically you are inside of an area code. Then it would, your line would connect to the area, then it would connect to the exchange would connect to your house. And this was your house number. That's just how the magic worked. Some of you might not realize this, but 20 years ago, you didn't get to pick this. Right? I used to live on Carling almost 20 years ago, and I didn't get to take my phone number with me when I moved 12 kilometers away. Nowadays, you know, who cares? You can get a phone number in a different province and they'll let you, because the systems have modernized. All right, so this is the basic matching patterns. Now we can do some slightly fancier pattern matches. I'm going to go on this side. My markers are. Let's say I know for a fact, hey, that's not cool.
That was scary, honestly.
I'm scared what it did to the recording, if anything. Okay, let's just say I'm going to search for anything that has A as a second letter. And I want it to be the second letter. Or maybe better, I want to find all the Dans, the Dons, the Dins, the Duns, the Dens. Right, so I want anybody who starts with D something, N, and then anything else. And I want to follow that rule specifically. The way it's set it up is something like this. right? So this is saying, give me anything that starts with D, has one letter and only one letter, and it has to have a letter there, and then an N, and then anything else. So this would match. That would match Dan, Donald, Dennis, Ding, Dong, but it'll match them all. Why? Because it matches that pattern, right? Starts with a D, anything next, then there's an N, and then the one thing next, and then anything goes after that. That one works. That's a slightly more complex pattern match. For example, if you're trying to find a postal code and you want to know everybody who's in K2C2, I don't care. Like that. So for some unknown reason you want to grab a subset of people that live in an area code that's K2C2 something 1. You don't want the K, 2P1, 2K1, 2N1. You don't care about that. You're trying to grab a random subset of people. Therefore, you could just say, I just want everybody that matches this pattern. It's a cute trick to do it. And the last one, I already covered this. So that covers actually most of the pattern matching. This will cover you for 90% of pattern matching that you need to do. 95% of pattern matching. There's very few cases that this won't cover you, unless you end up with some really strange, esoteric matches. Okay, they provided recently, they added something new called similar to. Since like is like this, so we're gonna go, it's kind of like that, but not similar to this. You can give it a series of rules. And believe it or not, I've never used it in my whole career. And I found out about it about 5 years ago. Just saying. It's not something, there is a use case for it, obviously, otherwise they wouldn't have created it. But it's not that commonly used, because I use the next one after this. But essentially similar to allows somewhat more robust. That link will bring you to the syntax. No, this is not going to show up on a test, and no, there's no labs attached to it. But I provided for proper information purposes. But it allows you to match strings. They're complete strings, just like does. But this thing here, the bracket, something type, something closed bracket means give me anything that has either B or D in it. That's what it's saying. The pipe is OR. One pipe is OR. The bracket is a set of conditions. That's what it's doing. But like I said, I'm not covering it past that one slide. And this next slide, which you learn this in level 2, so it's kind of wasted on you guys, but it's there. Anybody here ever hear of regular expressions other than the first time seeing it on this slide? Anybody ever hear of regex? The phrase regex? No? Okay. Hey? Regex is very powerful pattern matching. You can create complete rules, and the syntax is absurd, but it's really cool what you can do with it. You can return parts of the match back to the query. So you can search through a string and return just part of it out and add to match. But as I'm including a link, so if ever you're curious. But POSIX regular expressions, it supports that. That's what I use instead of similar to, because it allows me to do some really funky matches. For example, I can find any email address that follows a certain rule with it. Including, matching on a potential set of top-level domains with, if they got a period in their email address, that kind of thing. It's really powerful. I use it to match phone numbers. Specifically, there's a way of using this to match phone numbers regardless which way they're formatted. So if you're using the brackets and some of it have dashes and some of it have nothing, you can tell regex to actually ignore all the special characters and just match on numbers. Now the documentation, they sell a book for POSIX regular expressions. It's about 300 pages thick. Everything you can do with regular expressions. Whenever I need to do something, I go to Stack Overflow or Google and say, I need to match this pattern. And somebody's nice enough to give it to me. Okay. Multiple and grouped conditions. This is actually the second most important part of today's lecture. The first half of today's lecture, I should say. Like anything else, sometimes a single condition isn't enough. For example, you want to know anybody who's called Dan that lives in Cobden. You want to find all the Dans that are in Cobden, as opposed to all the Dans that live in Ottawa. Hey, if you look at my name in the phone book in Ottawa, I'm in Ottawa 10 times. It's not a good match. But there's not so many. There's not any Dan Goudreaus in Cobden, but not that I know of. But you can use and or. That's a really awful sentence to write. You can use and or to do multiple conditions. I'm about to erase this. Is there anybody still scrambling to try to write this out? Going once, going twice. So. All right, I want to find anybody whose name is like Dan, starts with Dan, doesn't care, doesn't care about the case. All right. So I'm doing a select something or other. Say. A select start from customers where name I like Dan, right? So it doesn't care about the case. But let's say I'm trying to find anybody who starts with Dan and everybody who starts with Joe. J-O. So that'd be the Johns, the Josephs, the Jojos of the world. And we put a new operator here. I'm going to put them both on right now. Okay, right now it's saying, give me everything for customers where the name is I like Dan, and I haven't decided yet what clause I'm going to put on here. Name like Joe, that's supposed to be a J. Let's go make it lowercase so it's easier to read. Okay, starts with either Dan or Joe. How much of you guys remember about your Boolean math in high school? Those of you that studied Boolean math. No? How many learned the concepts of and or in math? 1, 2, 3, 4, 5, 6 maybe. I saw a hand go up and down really fast, so I'm not sure if that was be counted. So we'll go with 6. Okay. And means that both clauses must be true, or means either clause is true. In this case, I want anybody whose first name is either Dan or Joe. Therefore, the clause would be or. Why? Because you can't have starts with both Dan and Joe. It's impossible. They're mutually exclusive clauses. Therefore, in this case, we want anything that starts Dan or Joe. So you'd have Dan, Daniel, Danielle, Joe, Joe, Joseph, JoJo's Bizarre Adventures. And somebody was waiting for it. I know you were. Right? Oh yeah, I forgot about John. Poor John. Dear John, you've been forgotten. I found a better word, a better name. Okay, so this would match this. That's what the or is for. So let's say you got two clauses you want to match against. You can do that. Alternatively, I'm going to throw in an and clause. My brain wasn't having such a hard time writing words today. All right, now I threw in an and. And this is where things get a little weird. Imagine somebody's last name ends in R, so it's, this guy ends in R, so we don't know. This one's ends in R, this one ends in T, that one ends in S, that one's in N, E, F, and R. Okay. The funny thing about how SQL treats this is it starts from left to right, or top to bottom, because I wrote it top to bottom, but you can write this all as one long command. And it goes basically, anything after the where clause, it starts parsing. Therefore, it'll do this, or this, and then this. And it evaluates certain keywords faster than others. For example, it thinks and's more important than or. Why? It's just the way it is. If you want to force certain clauses to be checked first, you guys remember in algebra, if you want to evaluate a part of the formula first, what do you put it in? That means that it'll resolve everything in the brackets. So the or will get resolved first, and then it'll match the and. Written this way, it'll find this one. No, yeah, that one, yeah. This one, and this one. Because we're finding starts with Dan, starts with J-O, and starts with J-O, ends in R. All it is logic, right? You just think, if you can actually say it out loud, and it makes sense to you in a sentence, then it's going to work. Whether or not it gives you what you're asking for, well, that's, your sentence writing skills. But essentially it says select everything from customers where the name is insensitive like Dan or insensitive like Joe, and it ends in R. That's the operative keywords in there. You can also search for other matches on there. You can see on the slides. There's a few other small examples. All right. Quick couple exercises. If I say ID is equal to 4, is it gonna, with theoretical, just assume that there is a record with an ID of 4. Will it find it? Probably. Where ID is greater than 4 and ID is less than 5. Think about that for a second. Can that be resolved? No. It's impossible to be less. It's impossible to be greater than 4 and less than 5. Well, it's not. But if you're working with whole integers, obviously, if you're working with a float, but if you're working with full integers, you can't. But if you say ID is greater than 4 or ID is less than 5, what are you going to get? True. You'll get them all, everything. Because everything is either greater than 4 or less than 5. You get absolutely everything. Whereas this one would give you nothing. This would give you absolutely everything because the two clauses basically complement each other to the extent where they just ignore, they erase each other out of the parser. Name like DA, well, that'll get match. Obviously, we did that on the board, so we know what that looks like. And then we go ID greater than or equal to 5, and name like that, or name is like this. So what would happen is it would find everybody whose ID is greater than 5, that ends in RAN, or it will give me absolutely everybody who begins in RAN. In other words, if let's say record ID number 2 starts with Randall, lowercase Randall, therefore you'd end up with ID 2 plus anything past 5 that matches. And then it gets a little more complicated down here, right? Down here is how you'd actually want to, it begins in RAN, ends in RAN, and it's greater ID, an ID greater than 5. That's basically the logic behind that. Yes?
Yes, the brackets.
That's for the brackets. You're saying resolve this first, then respect the OR, and then match this. You resolve the brackets first, so it'll find everything that fits inside the brackets, that matches the brackets, and then it steps out of the bracket and matches everything on the outside of it. That's just how it works. Okay, now I'll be doing a demo at the end because I want to get through the other slideshow. Okay. I have a brutal dry mouth today. Okay, the distinct keyword. The distinct keyword is used to return unique values. It happens, you only use it in one spot. Okay, it's saying return distinct name from users. The way distinct works is if it returns a distinct set of records. In other words, if you do a distinct on a single column, it returns to you all the unique values found on that column. So let's assume we have a data set that looks something like this. Okay. God, I wish my handwriting was better. All right, so here's 5 records in this virtual table. I'm saying give me the distinct names from users. So what would we match on? Well, we'd get Dan, Joe. Then we look at, oh, we've already got Dan in the list, that's good. Joe, oh, yeah, that's good because it's not in here. And then Dave. So if I did a select distinct name from users, it would only give me one Dan, even though Dan's in there twice, because I'm asking for only the distinct values in what's being returned. On the other hand, if I said distinct ID comma name, what it does, it compares. This was only matching on this column. This, when you do it this way, it matches the whole set. That means that 1 Dan, 2 Joe, 3 Dan, they're all going to get returned. Because if you take the ID plus the name, it's distinct. Because 1 Dan versus 3 Dan, they're different. If all I was returning was the names, then there's 2 copies of Dan. But if I return the ID and the name, well, therefore, the set of the data is distinct because you're returning more information. The more information you return, the less precise distinct is going to be. And I got a fun feeling the slideshow wasn't up on the screen. Oh, come on. There, that's what I was just talking about, was the distinct. Yay for Dan. Go organization. Okay. The other thing that's common that you do with your data is you want to change the order of the records that come out. In other words, the data you want to sort alphabetically. So for example, here I've got Dan, Joe, and Dave. And I want to sort the data coming out alphabetically. They've provided us something called an order by clause. And right now I put up the syntax really short. There's order by field name. Using this exact same data, if I told it to order by name, it would go Dan, Dave, Joe, and Jojo. If I did an order by name. Like that. You can sort by multiple columns by just comma delimiting them. So let's say you're returning 20 columns in your query, and you want to sort by last name, then their first name, and then maybe their city. Then you'd write it out like this. City. So we'd sort first by last name, then by first name, and then by city. And the only thing you can add on to any of this is the ascending and the descending clauses. In other words, you want to get the stuff sorted by price, most expensive to cheapest. You do something like this. Order by price descending and go from largest to smallest. My handwriting is deteriorating. Like such. All right, I'm going to do a little bit of a demo, and then I'm going to finish off the rest of these slides. Actually, I'm just going to kill these lights because right now, when I sit at the desk, all I see is my black outline of Dan's head because I'm backlit. Okay. So I'm using the ThinkCube database, just so you know. For example, there's the example of the starts with AN, and you can see right over here. And I wish I could make this bigger, but I can't. You can see all the names start with AN. Well, let's, right there, there's the AN right there. It's just the font's so small that. Now, if I were to say anything that has IN in it, and that's not an I, that's an I will go with UN. What the heck? UN works too. Here's everybody has the letters UN somewhere in their names. And if those of you have ThinkCube installed, you theoretically could be typing this stuff in too.
U or N or
No, UN. Anything that has U and N together inside of it.
together, right?
Yeah.
Oh, okay, I see.
Okay. Actually, let's make this lowercase just for everyone's sake. I know why I'm looking over there. I can see it on my screen here too. See, I did Dublin lowercase. Dublin's case sensitive. Strings are case sensitive in Postgres. If I do just like Dublin, or even equal to Dublin, it's not going to match because everything is, the city names are actually properly cased. So if I did capital D, and that still didn't work because Dan's a tool and he doesn't know how to type. There's everybody that lives in Dublin. Here's our happy little Dublin. So that's an example of matching for a specific place. And if I'd actually been searching for the right place originally, I would have shown you guys that, yes, it is case sensitive. Dublin is not found. But let's say I want to find anybody I'm trying to find anything that's got P.O. box in it.
Oh, because it's not mandatory, right?
Yeah, but what's going to happen is, do I know for a fact that they put a period in? No.
Yeah.
Do I know for a fact they put a period and a space in? No, because some people write P.O. space box. Some people put period, you know, P dot period dot O dot period. And I got a typo. There's absolutely nothing wrong with that. Yeah, I like the normal. Which you shouldn't care about that. But it's going to care today. Because the syntax is supposed to be case insensitive, but it's going to care today. Good job, Dan. All right, so here's our P.O. boxes. And it's matching the pattern for P.O. box. On the other hand, if I just did P.O. box like this, nothing, because it's a period. If I know for a fact that there's always something here, I could use just the underscore. Now we're going to match. Or we can get fancy. Say we want to find any city that has at least one space in it. Like Gray County, San Francisco is 2 words. I don't know why you'd want to run that query, but why not? Because you can. Now I'm going to go and I'm going to go select star from customers, and that returns 10,000 rows. Now I'm going to tell it to return the name from customers. Again, 10,000 rows. But a moment ago I was talking about distinct. I want to find all the distinct names. Now I have roughly 8,800 rows. That means that I've got a hair over 2,000 rows that have repeated names. That's what distinct does. It allows you to get rid of the same data. So if you want the unique values of something, that's what it's for. That's what distinct is for. That's its purpose in life. All right, now. So I'm going to start with everybody who starts with NA. I got 57 rows.
That one was in case sensitive.
Yeah, it's case sensitive. So I put it lowercase, but it's I like. Right here, see?
Oh,
Insensitive like.
yeah.
Unless they want to know anybody whose name starts with NA that lives in Berlin. And go. Now we got the 3 people that live in Berlin.
That's cool.
If I were to change this to an or, what is it going to give me?
Both.
Anybody whose name starts with NA or lives in Berlin. And if it just so happens that they start with NA and live in Berlin, they're going to be included for the right because they actually match both clauses anyways. $589 rows. Okay, that's basically how the where clause works. Those are, for today, that's pretty much what it does. Now, right now we're not sorted yet by name, so I could go order by name, and now you'll see this sort out alphabetically. There's alphabetical in one way. Let's say I want to know everybody whose names alphabetically go the other way. I can say do it descending. So see, we've got a Zoe here because we Berlin matched. Alphabetically, Zoe is valid because, well, it matches this but not that. But let's say I want to go order by city, descending, and then by name, oops, name, ascending. Which you're allowed to do that. So here's everybody in the cities. So it's sorted out the cities first and then the names in here. And theoretically, if I could find the duplicates in here, you'd probably find them. If there was 2 people with the same name in the same city. Eventually in here, we're going to hit, there's Berlin. So I keep scrolling past Berlin, keep going. Keep going right to the end. Here's the Belfasts and a couple of other ones in here, sorted first by city in reverse order and then by name. That's what the sorting does. So if ever you end up having to sort your data, pay attention to the ascending, descending, because that could be important. If you're trying to find out, in a few moments I'll show you guys some more stuff, and then you'll understand why the sorting is so important. Okay, transition back to here. Good. All right. I wish we had a remote for the lights at the desk. It would make sense, All right. Now, SQL originally, years ago, when it was first created, was to allow technical managers to write their own reports. Life was challenging back then, because if you needed a report, you had to send in a ticket to the programming department. The programmers would get around to it when they got around to it. And then you get a second paper delivered at your desk, a week later. You need to get all those TPS forms filled out, and you want the report for all the TPS forms? There they go. But you get this big stack of paper. Was it right or not? I know, you got the reference. What happened is this field was created to allow middle managers. In other words, managers have a slight modicum of technical capability. And I'm not talking about those guys the managers at Best Buy who can't find their shoelaces. Even though they're painted fluorescent and they're using a black light. Right? We're talking, managers actually have half a brain. Like my boss, the nuclear engineer. No, I'm not kidding. And you know, he actually doesn't do any SQL, he hates it. But this language is created so that people could get reports a little quicker. And one of the most important things is getting a dump of 10,000 records is great. And then the guy's got to count each one by hand. Not so useful. So somewhere along the way, someone says, you know what we really need? We need to create a whole class of functionality called aggregates. Aggregates are used to summarize data. For example, okay, ladies, how many of you were Girl Guides? Anybody? Any ladies here do cookies? Good job! I bought lots of cookies. Not from you, but I've bought lots of cookies. My daughter was a guider, and I had to sell lots of cookies. What's one of the things we had to do was keep track of how many boxes of cookies we sold, right? To make sure that our total was correct at the end of the day. Or as applicable if you went around trying to sell crap to people. Now, aggregates is the purpose of counting, summarizing, finding distinct value in data without having to write a program. A database server is optimized for summarizing data. For example, if you had 10,000 rows of data in the server and you run an aggregate on it, it does it instantly. On the other hand, you read your 10,000 rows of data and then you get Java to loop through it and do the math for you. Which one do you think is going to run faster? Or which one's going to run correctly? Yeah, Java? Are you using Big Indian, a small Indian system? Are you running on Mac, Windows, or Linux? Is the moon red today? I don't trust Java, as you can tell, right? It's a good first language. It's just, you know, I make fun of it. So aggregates are used for that purpose. You can use it in the field selection area. Normally, you pair it with another field. Why? A number means nothing by itself, unless for one specific aggregate, the number means something. And then, if you're using a display field, you must use a group by. I'm going to write one up on the board. All right, here's one. This aggregate's called sum. Anybody want to take a guess what sum does? And adds them up. The other ones you will see, AVG, also known as average, min, max. I think those are self-obvious. They give you the biggest possible value. Count. A lot of people, when they first start out, always get sum and count confused. Sum adds up the values, counts how many distinct values there are, or counts how many values are returned. That means that they will both return a number. Let's say there's 10,000 rows. Count will return 10,000. But if you're doing a sum and you're adding something up that's got big numbers in it, could return 1 million for the same data set, theoretically. Because this one adds up the values, this one just counts the number of rows returned. That's its purpose, is to count. And thus, we count the box of cookies and we sum up the money. To bring in the Girl Guides example back. I can't believe there's only one guide girl in here. I know there's disproportionate amount of women and men, but you know, I'm still surprised that the number's that low. Consider how many keep coming to my door every year. I'm always surprised. Okay, these are the basic aggregates. There's a lot more than this, and I actually provide a link somewhere. Postgres has an insane amount of aggregate functions. They even have, anybody here ever take statistics? Yeah, Postgres has got you covered, fam. all good. It's all good. God, my daughter hates it when I do that at home. She goes, Dad, can I get a glass of water? I got you covered, fam. Dad, stop that. But you know, it's fun. And those are, people go, what the heck did you just say? But it has a bunch of stats, including for doing medians and all the fun crap you do in stats. You can do it with the database. So if you got an insane amount of information you need to do some standard deviations, that kind of stuff, you can use the database and actually gives you just a number coming out. As long as you wrote your query correctly, it's actually faster than working with Mathematica. The other thing on here that I talked about is that you must use a group by. So right now I got the sum of the order line total. On the other hand, if I said, this is fine, this will give me the grand total of everything that's ever been sold as one lump sum. Right? So 10 million rows, it adds it all up and gives you one number. But let's just say we want to know what the total was by order. We can go and this is what you'd call a display field at this time. And if you ran this like this in Postgres, it would ask you what's wrong with you. MySQL is the only database server that will allow this particular command to run as is. Because it pulls a Mac on you. It looks at it just, I'm not sure you got that right now, but I'm going to assume I know what you're doing. And I'm going to take a guess. And it's going to be completely irrelevant data. It gets it wrong every single time. There's no way. What it'll do, this will give you the exact same thing as this. And it'll grab the very first order ID it finds and just say, hey, here's your display value. This is functionally equivalent in MySQL. Every other database server, you have to include something called group by. So you select the sum of the order lines and the order ID from order lines, and you're going to group by the order ID. So what it's going to do is it's going to go through everything and add up each order and give you a total by order. Now I'll be doing an example of it. What is it? Okay. Get the eye on the time. That's the group by. And you can group by more, if you have more than one display field, you have to have every single one in here. Otherwise, it's going to park. And you want to, this is where people get bit in the ass a lot by the group by clause. Because you know what it does? It groups from by the first one, then the second one. It does subtotals breaking down by each of the clauses. Which means if you aren't grouping by the one you want to group by first, your numbers are going to be wrong. It's usually good to work with a small subset of data at first, make sure you've got it right. Right, you sit there with your little handy-dandy pocket calculator or your smartphone, as the case may be, and you check the data, then you do your grouping. If it makes sense, congratulations, you won. If it doesn't make sense, well, you know, go work with your logic a little bit. And I already did the common aggregates there. Okay, one more topic, and then I'm going to do another little demo. And then I'm going to talk about the worst topic ever. Actually, I'm going to debate. I think I'm going to push it to next week. Just putting it out there. The one after this is joins, and it's not going to happen. Okay, aliases. Now, what's an alias? Other than what you see on the screen.
You can use, it'll change the name of the command to whatever you want.
Yeah, it's your thing. You're comparing it to Linux again, right?
Yeah.
Yeah. Well, this allows you to rename objects.
Yeah.
Today, my name is not Dan. I'm going to be Bob for the day. Right? Aliases allow you to rename fields / columns and tables. It's like magic.
Does it also do commands?
No. Aliases are for objects. SQL is not clever enough to let you rename commands. Because, well, that's probably not the best idea. Because then nobody would understand what your code's doing. Right? Imagine if you were taking Java and you could rename your for loop to, I don't know, George. For George.
It'd be hilarious. It's secure.
Yeah, and then you get fired. Okay. An alias is used to rename a field or a table. You can rename everything. It's also to make sure that your fields have a valid name coming out of the database server. Some servers, depending on what you do, and I'll show you guys when I start running the aggregates, the example of the aggregates, why the aliases are a good thing. And of course, I got a line here saying table renaming becomes important when you start using joins, which I'm not covering today. That's, later. But what does an alias look like? Aliases are stupid the way they've done it. If you're renaming a field, you have to have the keyword as. So select the count star as customer count. Or you could just go select name as customer name. But if you're renaming a table, there's no keyword as. Why? Because the guys are in two separate rooms that implemented the feature, I swear to God. Everything about the language is a little weird. Okay, I'm going to go back to demo time. Minimize this. And I want this. And I want this. I'm going to kill this light again. Don't you love how slow the button is compared to the light? You press the button, I'm having back to the desk. And that's our new modern lighting system. Yeah, I know. No sarcasm at all. It helps if I type it in right. All right, so say earlier I said this, right? So this gives me 114,000 and change. Yeah, 114,000 and change. So that's how many order lines are in ThinkCube, by the way. Now, remember earlier I was talking about people get confused between sum and count? I'm going to change this, so first of all I know what the heck my table structure is. 114,000 rows of data takes about a while. Okay, so I'm going to go select the count of the extended price. That's going to be 114,000 because it's exactly the same. Is that a valid number? If I want to know how many extended prices I have, that's great. On the other hand, I probably want to know how much the total was. By the way, that's how fast SQL does math. Returning lots of data takes a long time. Counting data doesn't take any time. So whatever magic number that is, that's a big number. That's how much was ever sold. And if I wanted to change this so that, I'll show you guys the joy of that error message. Here's the what the heck are you doing error message. And it's pretty obvious. Column order lines dot order data you must appear in the group by clause. It's telling you what you're doing wrong. MySQL just says error here, if it actually even does it. There's our group by. Okay, so now we return 43,000 rows. You can see what the sum is, and each of the order IDs broken down. That's our total by order. I really wish I could make that font bigger. Now, I want to know what the biggest order is. So Do this again, but give it to me from biggest to smallest. Blip. There it is. So the biggest order was 2,923 and I think 94 cents. So far, this is actually useful data. The only catch is, see right here, it just returns the word sum.
You don't know this one.
You don't know what it's summing. This is where your alias comes in handy. If I called it as order total and I hit run, you'll see right here the alias has been changed. Therefore, when it gets returned to your programming language, for example, actually, I'm going to ask this before I say this. Have you guys learned anything about arrays yet? Is that a word that's causing fear? Okay. Arrays are like lists. It's a list of values. Depending on the programming language you use, when you connect to a database and you run this query, when you loop through the results, it gives it to you one piece at a time as an array. This becomes one of your field identifiers. Otherwise, you're just getting a field identifier called sum. And the cool thing is you can do a min, you can do a max, depending on, let's say I want to change this to give me the max extended price, and I don't want to sort it. I don't want to sort it. So this will tell me what was the biggest order line for any in every single order. So that was the biggest order line. Well, it's not sort of there, but this order, that was the biggest line. That order, that was the biggest line. This order, that was the biggest order line. Now, there's some pretty nifty tricks you can do with it. And what's really cool, what am I doing here? Because I'm going to have to make this a little bit. Try to make it a little more legible for you guys. You can run multiple aggregates at once. And now we're getting some useful statistics out of that. So what's the biggest line? The smallest line? What was the sum of the order lines? How many order lines were in that order? And there you have it. That's all the basic parts. Now there is something you're not allowed to do. And that you can't aggregate an aggregate. Let's say I want to know what the average sum was. You're not allowed to do that. Because the aggregate happens on a line-by-line basis. So if you're going to aggregate an aggregate, you're trying to run something, you're trying to sum up an average information as it's being processed, and you can't do that. That's something important to remember. And next week I'll be showing you how to actually pull that trick off. Once I get past the joins. If I get past the joins.
So it's trying to do two things at once?
Yeah, essentially what's happening is you're telling add it all up, and while you're adding it up, figure out the average.
Okay.
Which you don't even know what the total is. Therefore, you can't do that. Theoretically, if you really wanted to, that would give you the average, theoretically. That took a little longer, right? Doing the math. So this will work because I'm doing the division. It's not ideal because as you can see, there's a performance difference. That took what, 1.7 seconds?
I didn't know what to name it either.
Yeah, I had no idea what to name it. And that takes 1.4 seconds. Doesn't sound like much, but it's still almost half a second. On a big server, that's going to be expensive. This is only 110,000 rows. If you're dealing with 1 million rows, factor it 10 times that, right? So when somebody runs a query, they want to know what the maximum price was, and it takes 10 seconds, they're going to ask you, what's wrong with your server? If you don't believe me, they're going to ask about 10 seconds. They're going to ask about 10 seconds. Okay, so okay, this is where I'm going to call it a day. Now the dates aren't on the board anymore, but you got 2 extra days on the assignment, so congratulations to make the best of it. That I decided to go that way because it's going to give everybody 1 extra lab if they have issues or questions. Otherwise, I'm going to just set tomorrow, the guys on Wednesday get screwed. So I'm making it Wednesday night, end of day. I haven't changed it in Blackboard yet, so don't panic, because they've told us to not make changes to Blackboard if we can avoid it. So I'll be changing the due date probably tomorrow once everything stabilizes. Okay?